In electrical engineering, there's a topic called difference equations that show up in the area of electrical engineering called digital signal processing. And so one of the things that I wanted to tell you about is that there's a relationship between difference equations and what you may have heard of. You may have heard of the Fibonacci sequence. So I wanted to talk about this, and I'm going to break this up into three different parts. Part one, we're going to go through an example of exponential growth that leads to a Fibonacci sequence. And then in part two, I wanted to look at the solution to a Fibonacci difference equation because the solution is interesting. It has some things that show up in nature, and that's something I wanted to cover in part three. Okay, so let's get started with part one. Part one is the exponential growth example. Okay, it's a little bit contrived. We're going to start with a pair of rabbits, and each pair of rabbits must mature for 1 month before they reproduce, and they reproduce exactly one new pair of rabbits. Okay, and so in turn that new pair of rabbits has to wait a month before they can reproduce, and they will reproduce exactly one pair of a male and a female rabbit. Okay, so let's get started with the example. Okay, so I'm going to draw a circle to represent a pair of rabbits. If the circle's not colored in, it's a new pair of rabbits, and so that pair of rabbits is going to have to wait a month before they can reproduce. Okay, so here I'm going to put the number of pairs that we have. We're going to keep track of that, and then we're going to keep track of the number of months. Okay, so the first pair of rabbits at month 0, there's only one pair, we have to wait a month. After a month, the pair is mature. So I'm going to indicate a mature pair of rabbits by coloring in the circle. Okay, so still after 1 month, we only have one pair. But then it gets interesting in the next month because this original pair that we draw this line, this is the original pair. That original pair reproduces a new pair of rabbits. We don't color that in because it's a new pair. All right, so now we have 2 pairs of rabbits after, at month 2. All right, so what happens at month 3? Well, at month 3, we have the original pair of rabbits, and they reproduce because they're mature. Then the new pair for month 2 is now mature. So this is what our diagram looks like. So we now have 3 pairs of rabbits after month 3. Okay, keep going. All right, the original pair reproduces. Their offspring matures. This mature pair of rabbits reproduces. So after month 4, you see the diagram starting to get big already. We now have 5 pairs of rabbits. Okay, so let's do this one more time. I would urge you to pause the video and try it yourself, and I'll give you a second to do that. All right, so let's get going. This is the a mature pair of rabbits, so we bring them down and they reproduce. This is a young pair of rabbits. They mature. They don't reproduce because it takes a month for them to mature. This is a mature pair of rabbits. They reproduce. This is a mature pair of rabbits. They reproduce. This is a young pair of rabbits. They mature. So we look at the total number of pairs in month 5, and we would see that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if you're familiar with the Fibonacci sequence, what happens with the Fibonacci sequence is each subsequent number in the sequence is the addition of the previous 2 numbers. Okay, so let's take a look at this. Back in our original example here, we start with 1. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. And so if you were making a prediction on the next level of this exponential growth, you'd have 5 plus 8, and you'd have 13 pairs of rabbits. Okay, so that's the idea of a Fibonacci sequence and how that relates to exponential growth, we would write a difference equation showing the number of rabbits at any given month n is the previous month, so n minus 1, plus the month before that, n minus 2. Okay, so this would represent the difference equation for a Fibonacci sequence. All right, so in part 2 of this series, we'll end up solving this difference equation with some interesting results.